So for this video, we'll be showing more examples on least common multiples. So let's start with question number 1. Which of the following is a multiple of 13? Now, there are various ways on how to solve this problem, but let's do the most simple one. We will list the multiples of 13. So we have 13, 26, 39, 52, 65, 78, 91, 104, 117, and 100. So basically what we did here is we kept on adding 13 per number, so 13 to 13, 26, and so on. Now we stopped at 130 since our largest number here is 120, which means that if 120 is a multiple of 13, then it must be in this interval from 13 to 130. So let's start checking. So for 95, clearly it is not in the multiples of 13, since if it does, it should be here. But it is not there, so we cross this one out. How about 120? Well, clearly it's again not a multiple of 13, since over here there's no 120 out here, so cross this one out. For 52, we can clearly see 52 is over here, so this one is a multiple of 13. How about 117? 117 is also here. So 117 is a multiple of 30. So our final answer is C and D, 52 and 117. So as simple as that. Let's move on to the next example. We have find the LCM of 15 and 25. Now, as we recall, there are 3 methods on how to find the LCM of a number. We have the listing method, the factor tree method, and the continuous division method. For this example, let's try out the listing method first, since the 2 numbers are manageable enough. So we have 15 and 25. Listing their multiples, we have 15, 30, else 15, 30, 45, 60, 75, 90, 105, and so on. For 25, we have 25, 50, 75, 100, 125, and so on. Now, we don't need to continue anymore, since you can already see a common multiple of the 2. That is 75 out here. See? Since the numbers before 75, in both of these, there's no common among them, so we conclude that the LCM of 15 and 25 is 75. Let's go on to our third example. Now we have find the LCM of 90 and 900. For this example, let's try using the factor tree method. So we have 90 and 900. Factoring these 2 out, we have 9 and 10. Since clearly it has a factor of 10, this one would be 3 and 3, and this one would be 2 and 5. For this one, we have, since it ends in 2 zeros, then it is clearly has a factor of 100. So we have 9 and 100 out here. 9, again, we factor it as 3 and 3. For 100, we know that 10 squared is 100, so we have 10 and 10. And this would factor out, like in the first one, as 2 and 5, 2 and 5. So now we can write these 2 numbers as in prime factorization mode. So we have, let's write it. We have 90 is 2 times 3 squared times 5. On the other hand, 900 is 2 squared times 3 squared times 5 squared. Now again, the trick here is that we check which among the 2 has a higher exponent on their similar factors. So for this one, if we have in the 2, we know that the exponent of the first one is 1. clearly, since 2 raised to 1 is 2. So we can write it out or not. So, but in other cases, we know that 2 raised to 2 is the higher exponent. So we circle that out. For the next one, since in the 3 in both cases have the same exponent, so we just choose either of them. So we have this one. And for the 5, this one has the higher exponent since it's 2, and the other one is only 1 exponent. So we then conclude that the LCM of 90 and 900 is equal to 2 squared times 3 squared times 5 squared, or it is simply this one. So we found that this one, their LCM is 900. So there are really cases like this wherein the LCM of two numbers is actually one of them. In this case, it's 900. Well, the reason being is that 90 is a factor of 900. So that's something to take note. Let's go on to our fourth example. We have find the LCM of 55, 65, and 143. For this example, let's try the continuous division method. So we've got 55, 65, and 143. So first, clearly, we know that 5 is a factor of 55 and 65. So we factor that out. And this would give us 11, 13. For this one, we just bring it down since it doesn't have a factor of 5. 143. Now for this next one, what else can we factor? Now take note that 143 is actually divisible by 11. Indeed, if we apply the divisibility rule by 11, we've got the sum of the alternating digits. In this case, 1 plus 3 is equal to 4, minus the other digit, which is 4, which will give us 0. So by the divisibility rule by 11, we know that 143 is divisible by 11. So we can factor out 11 here. And this would give us 1. We just bring this down. 13. Now what is 143 divided by 11? Well, that is actually 13. Now we can see that we have two 13s here, so we can factor again 13 out here. And that would give us, we just bring this down, so that's 1. This one would become 1 as well, and 1. So now, we can actually find the LCM already by simply multiplying this part and this part. But this is all 1, so we disregard that one. So moving this out here, we have that the LCM of 55, 65, and 143 is equal to 5 times 11 times 13, which is, let's try to manually compute it. So we've got, first 11 times 13 is 143, as we said a while ago. And 143 times 5 is 5 times 3 would give us 15. 5 times 4 would give us 20 plus 1, so that's by 1. This would give us 715. So their LCM is actually 715. Let's go on to our final example. Now this final example is a word problem. So we have the length of a video clip is 12 seconds. Sound like that. While a background song is 14 seconds. We then combine these two with the same starting time and on repeat. At what time will both the video and the music end at the same time? So, although it might seem hard at first, let's try to illustrate it. So first let's represent this as their starting point over here. Now for the video clip, let's say that's 12. This is 12 seconds long, and the background song is 14 seconds. So it's like, so we are tasked to find at what point will they end at the same time. So that means 12 and 14 would meet like over here. So when will that be possible? Well, that will be possible if we get their LCM. Now let's try a smaller example so we can clearly visualize it. Say if we have 2 seconds long and 3 seconds long, when will they end at the same time? So we've got 2, we repeat 2 and 2, and we repeat 3 and 3. This will become equal to 6, and this will become equal to 6. So they now meet when they reach 6. So the same idea goes here. So we simplify the LCM of 12 and 14. Let's use continuous division for that. So we've got 12 and 14 out here. They have a common factor of 2, so we've got 2. That will give us 6, and this one give us 7. Now does these two have a common factor? Well, they actually don't have any common factors anymore. So we simply multiply this one and together with this one. So we've got the LCM of 12, 14 is equal to 2 times 6 times 7. Now we just simplify this one. So we've got 6 times 7 is that is 42. Yep. Yes, it's 42 times 2 will give us 84. So the LCM is 84. Since we are asked for the time, we've got to write the unit, which is 84 seconds. And that is the answer for this problem. Now, as you can see, we have seen various use of the LCMs, various problems wherein we will encounter LCM. For the next video, we're gonna be probably dealing with its partner, the greatest common factor, or GCF in short. So that's all for this video.